Welcome to Storage Day. I'm Andy Warfield, and I'm a VP and an engineer that works across all of our storage services at AWS. I'm delighted to be here to welcome you to Storage Day today. And I'm also really excited at the set of presentations that we've been able to put together for this event. Storage Day is an opportunity for us to really dig in and tell you some of the details about storage, how we build it, how customers are using it. Today, we're going to hear talks across some really interesting themes. In today's talk, I'm really going to go through two things. First, I'm going to give you a bit of an overview and a refresher on our storage services and tell you some news about things that are happening. And I'm going to switch gears and talk about something that some of our most sophisticated storage customers mention a lot, which is a data strategy around how they think about managing their data and building applications on top of it. But first, I'd like to take a few minutes to talk about innovation. The technology decisions that you and your organizations are making today set the context for what happens in the future. Decisions that bring you more insight, let you move faster, and achieve more with the same effort are really meaningful because they ultimately pull results forward. They allow you to achieve your goals sooner. When we think about innovation and invention, we often think about these light bulb moments, these sudden transitions and discoveries that change everything. But I think we all know that innovation is actually not just those light bulb moments. It's actually all of the things that happen in between them, all of the work that it takes to power a flywheel that moves over years and years of work to really achieve velocity of delivery. At AWS, our ability to move quickly is one of our biggest strengths, and you're going to see it in today's storage presentations. Our innovation allows you to focus on your own flywheel and build applications and data investments that let your own organizations move fast. Let's talk about a single example of this kind of flywheel. And this is a storage-related example, and it's a really fun one to talk about. Jacob Rabineau is a US inventor that worked at the National Institute of Standards and Technologies. He's a serial inventor. He has over 230 patents. He, at one point, had a friend who was too short to touch the ground when she sat at a movie theater. And Jacob went off and filed a patent after developing a conversion of a conference proceedings, a book, into a stool that folded out and that he could put down under her feet because she couldn't get away with bringing a stool into movie theaters, but she could bring a book. Jacob went on to invent things like the first mail sorting machine and ultimately the first hard drive. In the case of the hard drive, he was asked to build a ferromagnetic storage device, right, using magnets to read data. And the original idea was actually to structure it almost like a book. It was a shelf of plates that a machine would pull out and that a two-dimensional actuator could move to read the data off of it. Rabineau decided that was way too complicated to build mechanically. He had a deep expertise in both mechanics and magnetics, and so he borrowed ideas from record players, from phonographs, and he invented the idea of a spinning platter storing data on it. And you can see in this picture, on this first hard drive, we didn't have an actuator and a head for every cylinder as we do today. Instead, he cut out a notch in each of the drives and allowed the head to move between them. And so Jacob was able to build the hard drive after presumably many successes and also many failures. It was his understanding and his investment in being able to devise these devices that really let him deliver. Now, that's 75 years ago. And at a larger context, hard drives have continued to evolve and really deliver over that period of time. We see movements into denser and denser drives, higher reliability, and ultimately into arrangements of drives that aggregate into storage. In S3 today, we actually have tens of thousands of customers whose data in their buckets are spread over 10 million physical hard drives or more. And so that flywheel of innovation that started with that first hard drive has advanced over 75 years to build absolutely amazing storage systems that we're all really passionate about building and that deliver incredible capabilities in terms of working with data. Now, hard drives aren't the only place where we innovate. Years ago, as SSDs were really emerging, at AWS, we realized that SSDs were going to be a profound impact in terms of storage systems. And what's more, we realized that building consistent low latency over NAND flash media was going to require a sustained and ongoing investment. So we developed the Nitro SSD, a hardware platform for flash that allows us to continuously improve and deliver performance advantages to customers. As you can see, over 3 generations of Nitro SSD, we've achieved continuous performance improvements. And by decoupling the hardware into a compute element and a separate media card, we're able to improve on both independently. On the media side, we benefit from increased densities and price drops in terms of NAND flash. And on the compute side, we're able to treat our SSDs as a service that we can deploy software updates to on a weekly basis. Nitro SSD is the default for all Graviton instances, I instances, as instance storage. It's used under EBS. And since I4I, it's also the default for all x86 instances. So this rate of innovation is something that's not just true of storage. In 2022, AWS introduced over 3,300 features and services. And 2023, as you'll see today, is already a really exciting year of enormous innovation and launches. So today is Storage Day. And so today we have a really exciting collection of talks from AWS teams that spend all of their time thinking about data. We're ruthlessly focused on it. Our job is to provide that foundation, storing, protecting, and delivering your data in a way that powers the flywheel of innovation as you build your own applications on top of it. We know that your data is absolutely central to innovation, your innovation, and we build storage services that allow you to get the most from it. Our storage teams consider ourselves successful when you don't have to think about storage. Our continued focus is to make sure that your data is always just there and available for you to use as you need it. Over time, you should expect our storage services to become less and less visible as part of your decision-making, because across the boards, our services are focused on improving and removing any unnecessary edges that mean you have to make decisions. And because this is the cloud, we achieve these benefits by delivering continuous improvements that mean you spend less time thinking about storage and more time innovating with your data. Let's think about an example of what that really means in terms of taking advantage of transparent improvements in storage over a cloud-based storage service. Here are 3 announcements about transparent performance improvements to our storage services. Last week, EFS announced, that's our elastic file system, support for up to 55,000 read IOPS and 25,000 write IOPS, making it easier to power ML research, financial simulations, big data analytics, and other data-intensive workloads on AWS. Today, on Storage Day, Amazon FSx for Windows is increasing the maximum I/O availability up to 12 gigabytes a second. That's a 6x throughput improvement. We're also delivering a 4x increase of up to 350,000 IOPS. And third, even on our archival storage side with Glacier, Amazon S3 Glacier has improved data restore time by up to 85%, which means that even your coldest, most archival data can be quickly pulled forward into data lakes and analytics tasks with very little preparation. Okay, so let's switch gears. I'd like to talk now for a few minutes about our portfolio of storage services and just give you a quick sort of overview of what's happening across all of our teams. This is really going to preface what you hear throughout the rest of the day today. And since it's Storage Day, and since we're 15 years from its launch, let's start by talking about EBS. EBS was one of the first AWS services. This year, EBS is crossing an important milestone of turning 15. It was launched as a scalable persistent block storage service for Amazon EC2 instances all the way back in 2008. Since then, EBS has grown to be one of the foundational AWS services that customers choose for reliable, high-performance block storage. EBS is kind of remarkable in that in the early days of developing virtualization in the cloud, we were working on what we called pizza box servers. I'm sure you all remember these if you've been around for a while. These were one-use servers that you would put inside racks, and without virtualization, you'd build and deploy software onto them. Those servers each had individual hard drives in the back of them, just little hard drives that you would use to store the system image. And as we moved to virtualizing and actually running virtual machines on those instances, we needed an analog for those hard drives. And that was really what led us to build EBS, the idea that you needed a system disk that could scale on demand as you deployed virtual machines. Now, over the 15 years, it is absolutely remarkable how EBS has evolved. Internally, there have been performance improvements upon performance improvements to the point that today, it's sort of grown to offer two significant products. GP3 is our general purpose, affordable, and still very high performance storage offering. And at the same time, over the past few years, we've launched IO2, a more SAN-like high performance, high durability block store that can be used for databases and other mission critical workloads. In 2023, Amazon EBS has handled more than 100 trillion IOs daily, and over 390 million EBS volumes have been created every day. Just last week, we launched EC2 M7i instances, powered by custom 4th generation Intel Xeon scalable processors. These custom processors are available only on AWS, and they offer the best performance among comparable Intel processors in the cloud, up to 15% better performance than Intel processors utilized by any other cloud provider. With M7i, we've improved the attachment to allow up to 128 EBS volumes to be attached to a single instance. This is especially profound for container workloads where customers want to run stateful containers. They allow you to run 127 containers, each with its own EBS block device. At the same time, we've also launched consistent multi-volume EBS snapshots, allowing you to take consistent snapshots across all of those attached volumes. Later today, we'll hear lots more about EBS on its birthday, including a visit from Matt Garman to talk about some of the history and his own experiences with the service. Really looking forward to that. Okay, S3, switching gears to object storage, is AWS's oldest service, older even than EC2 itself. S3 obviously doesn't need a lot of introduction. Customers love it because it's highly durable, completely elastic, and very cost effective. But a really interesting thing that's emerged in recent years is S3's strength as a sort of meeting place for data. Customers have built over 700,000 data lakes over S3, and they're able to amplify the value of that data through a large and growing set of integrated services. Things like Athena, Redshift, partner services like Snowflake and Databricks, and ML tools, and even programmable services using containers and Lambdas can all function over an existing data lake in S3. Now, I want to shift for a moment to talk about S3's fundamentals. These are areas that you might not ever see, except that it just works. Amazon S3's unique architecture gives customers an industry-leading combination of durability, security, availability, and performance at virtually unlimited scale, as we're constantly optimizing costs to be able to pass along those savings. Throughout the day, you'll see a set of focused talks that have titles about S3 fundamentals. And these are really interesting and fun talks. The engineers on the S3 team have taken time to put together talks that go into the details of how all of these fundamental characteristics of S3 are achieved. And so watch out for those through the day. Okay, moving on from object storage to file, the surface of our storage is super interesting in terms of services. AWS has a wide range of file services. File interfaces are the default way for applications to talk to persistent data, and those applications have a wide range of needs. But network file services are often one of the first bridge points that traditional enterprises think about as they start to move existing workloads to the cloud. And for this reason, we have a really interesting mix of offerings. Our FSx products are managed single-tenant storage targets. They represent a management experience that will be very similar to what enterprise customers are used to with on-premise offerings. And they've proven to be a really natural way to start moving data and accompanying workloads into the cloud. This is especially true with FSx Windows and FSx ONTAP. But FSx isn't just for cloud migrations. We've also found that the ability to provision a high-performance single-tenant file system is enormously valuable, especially for focused, high-performance computing workloads. We built FSx Lustre with an initial focus specifically on HPC customers, and then integrated it with Amazon Elastic Fabric Adapter for the fastest possible data path to storage. This shared high-performance namespace continues to be a wildly popular offering for HPC, and it's also been adopted by machine learning and generative AI workloads, which I'll tell you about in a little bit. Scientists love having a single shared namespace where they can write code on a developer desktop and deploy it on GPUs. Now, in addition to our FSx suite of products, we also have our elastic file system, EFS. EFS, in a lot of senses, is closer to S3 than conventional file systems. It's a fully elastic file system that was built in the cloud for cloud applications. It offers a similar durability model to S3 with 11 nines regional durability and a design to survive the loss of entire availability zones. EFS is a first-class cloud file system that serves workloads from machine learning to Lambdas to data lakes. So across block, object, and file, we have a wide portfolio of storage services, and you're going to hear some really cool talks and announcements from all of them today. But as I said earlier, our teams are working hard to shift all of your conversations when you design and build away from storage and onto the data that's being stored. And so when we talk about building applications around our data, our most sophisticated customers tend to talk about a data strategy that surrounds how they store and access data in the cloud. There are three pillars that we frequently hear talked about when people are thinking about a data strategy for storage. They want storage services that are comprehensive and interoperable with one another. They want them to be integrated and amplifying so that they can get the maximum value out of the data that's stored. And finally, they want governance to be something that achieves velocity rather than slows them down. Let's talk about each of these briefly. If we've learned anything in building storage services, it's that there's rarely a one-size-fits-all solution for data storage. Cost, performance, and access semantics are often in tension with each other in design, and we always want to meet our customers on their terms. This is why we have such a broad portfolio of storage options, and it's also why I won't be surprised to see us grow new storage services in the future. But at the same time, data is unique in that it has clear gravity in a way that makes early decisions sticky. A focus that you'll see in today's presentations and that you'll continue to see from our storage services is that we're working hard to help you make the right decisions on storage and provide tools that avoid these decisions being one-way doors. So I'd like to talk about two examples of that kind of interoperability that are helping customers move fast. The first one has to do with FSx. One example of this kind of interoperability is the idea of data repository associations inside FSx Lustre, or DRA. DRA allows you to associate a Lustre file system with an S3 prefix and to automatically hydrate Lustre with the contents of that prefix from S3 as the cluster is brought online. When we launched DRA, it had a really simple check-in and check-out semantics. When we were first reviewing the design, we were talking about how we could quickly scan the prefix and arrange a fast copy of all of the data from S3 into the newly provisioned Lustre cluster. And the idea at the time, driven by a lot of conversations with HPC customers, was that they would move that workload over, and then they'd run a big job against the data, basically ignoring the state of the data in S3, and then finish the workload and move the data back in. But after FSx Lustre launched, we learned that customers actually wanted quite a bit more. They wanted to be able to continue to work in both S3 and Lustre and move data back and forth between two, potentially producing data on one side and consuming it on the other. We're finding this especially true today. The integration that we've sort of worked through over time with Lustre is to use S3 events and allow those data changes to be propagated in both directions as they happen, iteratively improving the sort of consistency between the two and the rate at which we do those transitions. Today, we're finding this is really, really true, especially in large-scale machine learning and generative AI workloads. The thing that you see in these environments is the data scientists come from a statistical background, right? They're mathematicians and ML experts, and they're used to working in environments where they just have a shared file system. There are really four types of data in these big ML environments. Customers care about the training data. They care about the checkpoints of their jobs as they run. They care about their logs, and importantly, they care about their code. And a common pattern is developers work on individual desktops for development, but then they deploy to more expensive GPU-based instances to actually run jobs. And they just want a single unified file system namespace for all of those things. Lustre has been really successful as an option to allow you to step in, still keep the authoritative copy of that data in S3 as a low cost and also highly durable and secure file base, but bring the active copy of that into a shared namespace where developers can really collaborate. LG AI Research is one example of a customer that's done this. They developed EXO-1, which is an internal 300 billion parameter multimodal model, a foundation model, used for internal generative AI-based tasks. LG was able to use both Lustre and scalable clusters inside Amazon FP instances to build this GPU hardware directly and finish the entire development from ideation to delivery inside of a year. Now, FSX Lustre is an example of bringing the data in S3 over to file to be able to work with it while keeping those two things in sync. There's another set of customers that really want to pull the file and S3 data in the opposite direction. They want to be able to have file interfaces, to have simple applications interact with file directly over S3. And so about 18 months ago, the S3 team sat down. We actually had an offsite in Vancouver and talked about how we might provide an offering like this. There were a bunch of file connectors to S3 that we'd seen in open source, but we really wanted to move towards something that was high performance and could be supported by AWS for those customers. And so we wrote a bunch of papers and talked about what an ideal, faithful file implementation over S3 would look like that really played to S3's strengths. And today, we're launching MountPoint into GA. Now, MountPoint actually is a Fuse, or user space-based file connector that exposes just the S3 semantics over file. It doesn't support directory renames. It's not a full POSIX file system. It's a lot similar to a data lake file system like HDFS, if you're familiar with that. Over the past year, we decided to start building MountPoint. We launched it as an alpha in open source, and we've actually been developing it in conjunction with customer feedback and commits over the last 6 months as we approach alpha. The back end of MountPoint is a really cool bit of technology that's been developed by the Amazon SDK team. It's called the Common Runtime. And what the CRT does is it captures all of the best performance practices for S3, things like connection health tracking, retries, parallelizing connections, and it makes them all automatic. And so when you mount an S3 prefix over MountPoint, you get a local file system attachment that allows you to access files with throughput that aims to saturate the local network without having to do any special performance tuning. That investment in the CRT and our investment in clients like MountPoint is something that's not just true for file. We're doing the same thing with data lake connectors like S3A, and you'll see us move more toward integrating on the client side in terms of making the best possible performance experience with S3 seamless for customers. MountPoint and Lustre RDAs are two really cool examples of our storage services moving closer together. We have plenty of room to improve here, but our focus really borrows from the idea of zero ETL in databases. Broadly, we're working to evolve our storage services to make sure that irrespective of where your data lives today, you have the tools to make it available in the best possible structure for your application designs, even as those designs change and your needs evolve. Another area where we continue to deepen our capability is around data movement with AWS DataSync. AWS DataSync makes it simple to move large amounts of data quickly and securely between on-premise, edge locations, outposts, and AWS. Using AWS DataSync, customers can move their data at scale between S3-compatible storage on other clouds and AWS object and file services, making it fast and simple to migrate data from other clouds to AWS and to streamline business workflows. Today, we're announcing that AWS DataSync is expanding the set of cloud providers that we can move data to and from. In addition to support for Google Cloud Storage, Azure Files, and Blob, DataSync will support copying data to and from Wasabi Cloud Storage, DigitalOcean Spaces, Oracle, and more. Returning to our overall view of data strategy, the second big idea that's really important in building a strategy for data is to think about integrations of that data with other services and how those integrations are amplifying for your flywheel of innovation. In other words, we want to avoid your data being stuck on an island and make sure that it's easy to connect that data to whatever tools or services you need to get value out of it. And so from this perspective, we can really think of our storage services as a hub that sits in the middle of all of these other services that let you take value from your data. We have storage in the middle with analytics, databases, and ML sitting around the outside of it. We offer the most complete set of purpose-built databases, and we're continuously adding new features to them. In 2009, we started with Amazon RDS, which provided a scalable and easy-to-manage relational database. Our customers prefer highly optimized databases, though, not jack of all trades and expert of none. And that's why we now offer 8 purpose-built databases that are tailored to specific individual use cases and that are evolving new zero ETL features to make that data integrate directly with storage services like S3, so that storage can act as a hub to move that data between other modalities of building on top of it. That same approach of breadth and depth is true in how we approach analytics at AWS. We pioneered cloud analytics with the launch of Elastic MapReduce, EMR, in 2009. that now supports several open source frameworks like Apache Spark or Apache Flink. We did the same thing with Redshift for data warehouses and Kinesis for real-time data streaming and processing for our customers. Each of these new services helps you derive more meaning from your data by connecting the dots. And this bridge from databases on storage and analytics on storage into the explosive growth in machine learning is just really a continuation of working with your data. AWS machine learning capabilities offer breadth and depth for builders of all levels of expertise. They range from ML infrastructure for expert ML practitioners building huge generative AI foundation models to fully trained AI services that are easily integrated into your business processes. At each layer, we remove the undifferentiated heavy lifting so that you can move faster, from silicon to software to APIs. Our TRN1 instances, based on our custom AWS Trainium chips, offer the most cost-effective ML training in the cloud. Optimized versions of the most popular deep learning frameworks, including PyTorch, TensorFlow, and tools from Hugging Face, offer the best performance for the cloud. Meanwhile, services like Amazon SageMaker make it easy for developers to create new ML models. And at the top layer, we have AI services with built-in machine learning like Amazon Transcribe and Amazon Textract so that you can add AI capabilities to your business applications and workflows without needing any ML experience at all. On July 26th at AWS New York Summit, we announced the general availability of Amazon EC2 P5 instances. These instances are optimized for generative AI and powered by NVIDIA H100 Tensor Core GPUs. P5 instances are ideal for training and running inference for increasingly complex LLMs and computer vision models behind the most compute-intensive generative AI applications like question answering and speech recognition. Stepping up a level, Amazon FSx for Lustre is the storage infrastructure for EC2 Ultra clusters, delivering data at hundreds of gigabytes per second of throughput and millions of IOPS required to train large foundational models. Ultra clusters give customers on-demand access to a supercomputer to cut model training time for large and complex models from months to weeks or even days. Now, it's really interesting to see this progression because for years we've seen customers building data lakes on top of S3. As I said, 700,000 data lakes in there. And customers have grown initially from data on their own premise hardware to S3, to building analytics tools around them, to now today starting to dip their toes or potentially build huge sophisticated machine learning models on top of them. And that data in our storage systems acts as a hub that allows you to progressively build that value on top of it through all of these integrations. Now let's talk about the last pillar of a data strategy. And this one's going to be fairly brief with more exciting announcements to follow through today and through the rest of the year. This is governance. Now, let's think about governance through a quick car analogy. Why do cars have brakes? They have brakes so that they can slow down really quickly, right? But why do cars need to slow down quickly? Well, they need to slow down quickly so that they can go even faster. Better brakes on a race car can do even more to win a race than a bigger engine, because a bigger engine can be heavier and use more fuel. Because brakes add safety, they increase the driver's confidence and allow the driver to be more agile and nimble on the course. This is how we think about governance. Governance done right allows us to enable our developers to not worry about all sorts of other policy and guardrails in their work and just work with data. And so we really view governance as an accelerative guardrail for development. Last month, we introduced SnapLock on Amazon FSx for NetApp ONTAP, making it the first and only fully managed cloud file service with worm data protection capabilities. With SnapLock, customer data is immutable and indelible, so it's protected against modification or deletion of files. SnapLock acts as a line of defense against ransomware attacks targeting your backup copies. SnapLock's a lot like Object Lock on S3, which provides the same kind of capabilities for object data. And what we learned from Object Lock on S3 was what we thought was a compliance facility allowed customers to move faster and build with more velocity. Data protection serves as guardrails for good corporate governance strategy. AWS continues to innovate and deliver capabilities to help customers protect and recover their data from incidents, including ransomware. Today, we are including AWS Backup Logically Air-Gapped Vault in preview. This logically air-gapped vault is a new type of vault, storing immutable backup copies protected in a set of service-owned accounts that are encrypted with service-owned KMS keys. It simplifies cross-account and cross-organization data recovery, allowing for faster cross-account restore and creating greater isolation of backups. These are just two examples for today of what we're building around governance, and there's plenty more coming through the remainder of the year. So that's it for my introduction for the day. The rest of the talks are really, really exciting, and we have some incredible folks coming and talking about all of the services that are being built. There's a whole day of sessions ahead. So please stick around. I hope that you enjoyed the day, and thank you for attending.